Hi class, we are on the last section, which is 710, classifying chemical reactions. So we are going to cover, we've covered here precipitation reactions, acid-base reactions, gas evolution reactions, oxidation reactions, which is combustion reactions. Again, if I do give you anything on this, it's going to be pretty much definitions and what it is, but nothing more into that than that. So classifying chemical reactions. The scheme is based on the type of chemistry or phenomenon that occurs during the reaction, formation of precipitate, transfer of electrons. A couple times I've told you about, I brought up a double displacement or double replacement reaction. The displacement or replacement mean the same thing. We're actually looking at the reaction, not the compound, but the equation of how it's set up. So we can classify that as well. So we're going to look at synthesis or combination, decomposition, single displacement or single replacement, and double displacement or double replacement. And these are the general equations for those. And the A, B, C, D, they represent atoms or a group of atoms. So a synthesis reaction is, or a combination reaction, you can find the terms are interchangeable. Some books will use synthesis, others will use combination. They are very simple, if I can put it here. A plus B, so two compounds make one compound. They are joined together, they combine. So in this case we have sodium chloride and we end up with salt. So this is a very good example of a synthesis reaction. You have two, and it doesn't necessarily have to have two, but everything at the end is one. It combines as one compound. So you start here with sodium, that's a solid, chlorine, that's a gas, but when a reaction occurs, we now have the sodium chloride that we know as salt. Synthesis reaction, here's another one where you see we have sulfur as a solid, oxygen as a gas, and we end up with SO2. So we have two reactants, but one product. This is very, as you see, A plus B produces AB, which is joined together, not a separate compound. And then here are more examples of that. A plus B produces a compound. Again, here is magnesium oxide. So we have magnesium solid, that's a ribbon, and we have oxygen. And when you place the ribbon in the presence of oxygen with the flame, it can combust, and you see we now have magnesium oxide. So we have this, two reactants, one product. And you can see where it is magnesium, 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 and then oxygen here is taken from the air, and now you see it is in a pattern of magnesium oxide. Okay, so decomposition reaction is exactly what it sounds like. It's decomposing. So here you see a decomposition reaction. It is the opposite of a combination synthesis reaction. So here is mercury oxide, and it decomposes. So it's separating into mercury, which is a liquid, and oxygen, which is a gas. So this is the opposite of a synthesis. So if we go back here, you see the synthesis is A plus B produces AB. Now this is the opposite, or if you want to say the reverse of that, the decomposition, it decomposes from one reactant into more products. And here is another one here where you have water. But if it decomposes, we can put it back into the hydrogen gas and the oxygen gas. So one reactant, two products. And here's the general AB splits into two or more products. Here is more examples of that. So decomposition, think decompose. Single replacement or single displacement. Look at, I just copied it over. This should say replacement, because if you do a search for this, it could come up as either one, displacement or replacement, but they mean the same thing. So this is, let me explain. You are dancing with somebody on the dance floor, and then somebody wants to dance with you. So they ask to dance with you while you're dancing with somebody else, and that person leaves, and now you have a new dance partner. That is exactly what's happening here. There is a single replacement or single displacement. One of the cations or anions leaves, and another one comes in. So that's what one element displaces another in a compound. So when metallic zinc is immersed in a solution of copper 2 chloride, the zinc atoms displace the copper. So what you see is that the zinc is going to come out of the solid, and the copper is going to actually make a film here while the zinc chloride, the ions stay in solution. So these are in ions, the copper's in ions, but this time it's going to switch. The copper's going to go into solid and the zinc's going to be in ionic form. So it's switched them out. And that's what you're seeing here. You, A plus BC, one replaces the other. So like I said, if these are dancing, this person comes in and it pushes that other one out. And now this one's by itself. And now you have another compound. So here you have zinc as a solid and you have hydrochloric acid. And in the presence of the hydrochloric acid, the hydrogen gets kicked out and it now produces a gas, and we have zinc chloride. And so these are ions in solution. Here we have iron and we have copper 2 sulfate, and the iron will kick out the copper, and the copper now is by itself as a solid, and the iron sulfate stays as ions in the solution. So here we go. Here's a visual of what I just covered here. There is zinc as a solid, hydrochloric acid, all this bubbling. That is the hydrogen leaving, allowing the zinc to come and take its place. So that's what all this bubbling is that you see. Double displacement is exactly what it sounds like, where you had one dance partner and that partner left. Now you have two couples on the dance floor and they completely switch partners. That's a double displacement reaction. So here we have AB plus CD, and this produces AD plus BC. So we have a double displacement reaction in the general form. This is the general form. So when I was talking about it earlier, where you have to switch ions, this is exactly what I was talking about. When you have to switch the ions to see what the solubility is. Double displacement precipitation reactions are a form of double displacement reactions. So here we go. They are double displacement reactions are precipitation reactions, acid-base reactions, and gas evolution reactions. So here are more examples of that, where you can see that the silver here goes with the chloride here, and then sodium goes with the nitrate here. So we are completely replacing each other on this reaction. Now this one down here is not, oh yeah it is, sorry, I was going to say it's something else, but it's not. I'm not going to say anything. Double displacement here is barium sulfate. So we have sodium sulfate in the presence of barium chloride. They switch partners. We end up with barium sulfate, which is a solid, and ions of sodium chloride. That's a precipitation reaction. And then we are looking at a combustion reaction. So now we're looking at a combustion reaction. I apologize, these moved way more than they should have. Oh no, I didn't. These are, I'll explain them right now. So let's look at a combustion reaction. If we go all the way to the front again, we see that a combustion oh, it's not on there. A combustion reaction should have been listed. I don't know why it wasn't on what they gave me, but here's a combustion reaction. You have a hydrocarbon in the presence of oxygen. You may not always see the triangle at top, but what a combustion reaction always produces carbon dioxide and water vapor. The energy may not always show. In this case, it's showing that it's an exothermic reaction, but this plus energy, that's not usually included when you're looking at reactions. So it's a hydrocarbon in the presence of oxygen gas produces CO2 and H2O. I found another chart to make it easier. Okay, so that's what you're dealing with here. You have a hydrocarbon plus in the presence of oxygen produces carbon dioxide and water, and this is showing you plus energy. This energy is the heat that you feel. So this is methane gas that in the presence of oxygen, once it's a combustible, it produces CO2 and water and the heat that you feel from it. Here is propane. Propane in the presence of oxygen produces CO2 with water, and the energy you feel is that heat that comes off of it. So this is a combustion reaction. The products are always CO2 and water. And again, here is a chart to show what I just covered, the combination, decomposition, single replacement. I found one that had combustion on it. Don't pay attention to this 2 here. As you can see, we have it here, an example of it. I just wanted one to show a general equation of combustion. Okay, in the classification flow chart, synthesis, decomposition, single displacement, double displacement, and combustion is also another one that they don't have listed on here for some reason.